As far as I know, this is the oldest running digital computer in North America. It's a Bendix G15, a full-fledged vacuum tube computer from 1956. And actually, I'm pretty sure it's the only running Bendix G15 in the entire world, which is pretty wild in and of itself. But when you start considering the history of this machine, it gets even crazier, because this machine was designed by Harry Huskey, who worked with Alan Turing and Tommy Flowers. And not only that, a lot of the design characteristics that Alan Turing built into the Pilot Ace found their way into this machine. This is kind of like the spiritual successor to the Pilot Ace. So this is not only the oldest running digital computer in North America, it has an extremely strong link to the birth of computing. Everything that we can do today, the camera that is filming me sitting here talking, can all trace its lineage back to this machine, and it can trace its lineage back to Alan Turing and Tommy Flowers. That's just absolutely mind-blowing to me. So how on earth did such an important machine find its way into this room? Well, this machine is on loan from Bob over at System Source Museum. And if you haven't heard of System Source Museum, go check them out immediately. I say this every episode and I mean it from the bottom of my heart. System Source Museum is one of my favorite places on the planet. And Bob is just an excellent person. He gets these machines like we get these machines. And he wants to see them up and running because a running machine can teach us so much more. And so that's why he sent this G15 all the way down to here so we could get it up and running. And in the previous episode, we did just that. We loaded up the diaper, which is a hilarious name for a program. It stands for Diagnostic Program for Easy Repair. But it's essentially a program that has a bunch of diagnostics on it. We loaded it up, ran it to completion. Every time it passed a test, it would ring the bell. And when it got to the end of the tape, it rang the bell like 6 times in rapid succession. It was absolutely awesome. So the next step is to load up Diaper Reel 2, which has much more in-depth and complex tests on it. Like it's going to test multiplication and division and some other really tricky things that the Bendix is capable of. And I'm actually expecting that reel to fail because we have some modifications going on the inside with some wires soldered into strange places. And one of those wires I know for a fact is broken. And so I'm expecting us to butt our heads up against that. But before we can even get that far, we have one huge, massive problem that's preventing us from just throwing in Intercom or Algol and just writing new software for this thing. And that is that, well, the machine needs input and output. And the input and output primarily is done through the typewriter. And this typewriter is a pretty interesting typewriter because it has a 28-inch platen. It is massive and ridiculous, and I love it. And it seems to be receiving output from the G15 just fine. I mean, aside from the fact that we need a new ribbon and a little bit of adjustment going on so the hammers hit the platen a little harder, but the input into the G15 from this typewriter is not quite right. It does work somewhat. I can press S and I can press carriage return, and those send signals to the G15, and the G15 knows how to go on from there. But the numeric portion of it just doesn't work. Like I can't hit any of the letters, numbers 0 to 9 or letters U to Z, and some of the other letters on the keyboard should be doing stuff. Like I should be able to hit P for photo tape reader, stuff like that. And that just doesn't seem to be working right. And I think it's because somebody modified this typewriter to essentially turn it into a printer. But if you just wanted a printer, why remove the output functionality of it? Like it doesn't make any sense to me. So what I'm going to do today is I'm going to take pictures of the PCB that's inside of the typewriter, make sure that we have good documentation of it, and then I'm going to try and de-modify it. We're going to try and get it back to original specification, so that way we can plug this into the G15, and now we can start using it as it was originally intended. But that's going to be pretty difficult because there's a lot of wires and a lot of soldering that needs doing. So let's get this onto the bench and get started. Now that we've got this behemoth of a typewriter up on the bench, let's go ahead and see if we can get it apart. And in order to do that, I need to tilt it up onto its backside. Then on the bottom, the 4 rubber feet are actually screws that thread into studs and hold the entire bottom piece on. So we'll just unscrew those and the entire bottom piece kind of rotates down. Now, in order to get the bottom piece completely free, we need to undo the 2 plugs that plug into the side here. They're not locked in with screws or anything, so you can just kind of slide them out and unplug them. And with them unplugged, we get the bottom half completely free. This thing is wild looking inside. And this is not the first time that I've been in this thing. We did have it apart earlier, so we could get to work on some of the mechanical aspects of it, clean it up, and try to get it typing well. And it seems to be working mostly okay. It definitely needs a new ribbon. Got one of those on order. Don't worry, we're gonna try and get that in there this episode, depending on how shipping in December goes. Who knows, it could be lost in the mail. But today is not a focus on the mechanical aspect of it. We really want to get the electrical aspect of it going, and somebody's been in here and modified it. I can see that there's some cut wires up here as well as down here, and a bunch of stuff has been completely resoldered. Now, some of these cut wires might not have been modifications. They might have been that way from the factory, just extra wires run up there for potentially different versions of the typewriter. I don't really know about that, but down here where all the wires are soldered together in kind of one big mess, that's definitely a modification. And then there are jumpers that jumper over specific diodes, and I think we can maybe remove those jumpers and get this thing back to some semblance of factory. And I'm not gonna just like desolder things and just kind of take a guess at where they go. We do actually have the schematic from the theory of operation manual. So we can actually see what the diode matrix should look like, and we can see what keys should connect to what. So I can actually start beeping out connectors on the pin to specific wires and then figure out where that fits on the diode matrix here and make sure that the diode matrix is correct as well as all of the diodes are good, because we may have a bad germanium in the middle of here somewhere as well. Let's start by repopulating the resistors that had been removed. I previously resoldered a few of these, but it looks like in all 6 different resistors have been either removed completely or had one of their legs lifted. They're all just simple 1/4 watt carbon composition resistors, and they're all acting as pull downs to the negative 20 volt rails, so I can replace them with these modern resistors, no problem. After the resistors, let's get this insane mod wire out of here. I previously put fresh tape on it to keep it from shorting out to anything else in here, but other than that, this is how it was when I got the typewriter. About 20 wires have all been tied together, and I know that's not right. I'm going to add a little fresh solder to break the connections loose, then I'll separate each individual wire. It's tedious and finicky because nothing is stable and the solder is old, but eventually I got everything free and spread apart. Then I just need to figure out where each wire goes. Thankfully, the manual is pretty helpful here. For example, we can see on the schematic that the letter Z goes into plug number 1 on pin Y. That's right, Z is Y. Confused yet? But that means I can put one probe on pin Y of the plug number 1 connector and check to see which wire has continuity. Once I find it, I can solder it back in place. Thankfully, the PCB is marked with the pin names, so I just have to find the letter Z and solder it there. It's a little hard to see, but from left to right in this shot, you can find tab, S, and 0, and the rest of them all look like this. And now that we've done it once, we have to do it 20 more times. Find the letter or number to work on, look up what pin on plug number 1 it is, check for continuity from that pin to a specific wire, strip the wire, add fresh solder, find the appropriately marked place for it on the PCB, solder it down, and repeat for the next one. I got my workout in for sure, as I was constantly going from one side of the table to the other, but after surprisingly not that long, check it out. The typewriter is looking much tighter inside. The final thing that I did was remove a few jumpers that were shorting across a few of the diodes. And with it all back to factory spec now, I think this thing will work beautifully. However, speaking of the diodes, I do want to try and test them if possible. Unfortunately, because they're all arranged into a big matrix, it's impossible to isolate a single diode for testing. You can see that we get a decent reading in the forward direction, but the diode matrix just blasts our reverse direction reading. We'll just have to do trial by fire for these diodes. But now that the typewriter is back to normal, what was modified? You can see on this diagram that carriage return, space, minus, tab, 0 through 9, and U through Z were all disconnected and tied together. Then bit level 5 was disconnected and tied into that mess. That means that if any of those keys are pressed, it would send a 10000 code, which would get interpreted as a 0. Then, to confuse matters more, they removed R21, R22, R25, R27, R28, and R34. Then they jumped across diode 21 and diode 30 and connected the jumped diode 21 directly to bit level 1. I think we're seeing two different modifications here, one superseding the other. Either way, I can't make heads or tails of it, but at least we have it archived for future reference now. All right, typewriter's all back together. Let's just give this thing like a quick sanity check. Make sure I didn't make anything worse. So I've already brought AC up. We'll hit the reset button here. That'll bring DC up. The sequencer should be going through. We should see the paper tape reader kicked off. It should be reading in the number track right now. It'll stop, then it'll read in the first block of diaper because that's the program that I currently have loaded into it. When it finishes reading this, it's gonna hit a pause and wait for me to hit the go switch on the typewriter. When I do that, it should punch some stuff out on the typewriter, and I think that'll be a pretty good indication that we haven't made anything worse. So it's currently waiting on me to do that. I'll go ahead and flip the go switch. Yeah, it hit the typewriter. It's reading in the next block. I think that's a pretty good sign. It didn't actually type anything out because, again, bad ribbon and probably totally maladjusted, and that's a problem for future David. All it would have printed out is just the number 1 like 6 times. So really, we're not missing anything fancy there. But it read in the next block. I think that means that the system is working. Let's go ahead and hit S here. And yeah, it's gonna read in the next block. It's gonna continue on its way. And honestly, that's actually about as much interaction as the diaper is expecting from us via the typewriter. There is a test about midway through, test number 7, I think, that wants you to punch in a random number and then hit S. And we've been able to skirt by that test anyways. So we really need something more involved to properly test the typewriter out on this thing. So I'm gonna punch out a new tape and we're gonna try something pretty interesting here. Time to punch a new tape, which means I get to use this awesome faucet punch again. I've always been calling it facet, but you guys let me know that it's pronounced with a long A. Anyways, I load up the blue paper tape that Lloyd sent me. This stuff seems to work a little more consistently with the photo tape reader. I'll loop it around the correct tensioners and then around the bottom, then slip it into the 5-level guide and through the punch mechanism. And once it's out the top, I'll thread it through this tensioner sensor here. I have no clue what this is actually for, but we might as well use it. Then it gets a spiral around the back post and looped onto the top reel. I'll just tape it in, give the button a few presses to make sure that we're loaded correctly, then hop on the laptop, set teraterm for 608N1, load the binary file, and send it over. And away it goes, making an absolute racket. I love just sitting and watching this thing work. Watching the tape spool onto the top reel or getting pulled through all the different tensioning wheels and being able to see the actual data stored on the tape as it flies by. Or most importantly, watching this thing create a mountain of Chad confetti. I'm still vacuuming this stuff up, by the way. I desperately need to build a bit bucket for this thing. But once I click send, the process takes about 5 minutes and it's purely a hands-off thing. I don't need to babysit it or anything. It just sits there and creates new data tapes perfectly. And of course, at the end of it all, I do get the satisfaction of vacuuming up all the bits that fell onto the table. Tape is punched, we've got it mounted. Let's turn the DC on here. We're gonna hit reset. That's kicked off. It should start reading in the tape. Yep, there we go. So the first block of this is just the number track. But the second block is where it gets interesting because this is not a diagnostic tape. This is a real deal, legitimate program that's going to require input from the typewriter and it's going to give us some interesting output, hopefully, if I can figure out how to make it work. I've been kind of struggling with this for a while. Actually, I've got a bunch of handwritten notes over here. So if I look at my handwritten notes here, we want to do console switch to go. and it should start reading in more blocks of data off the tape, okay? So it's gonna do this for a long time. It's gonna sit here and read blocks off the tape for, I think like 16 blocks or something. So it's gonna take it a while. So we'll just sit here and twiddle our thumbs until it's done. Okay, all blocks of tape have been read in, so we're gonna take the compute switch, put it back to the center here, and then we wanna turn the enable switch on, and we wanna hit the letter P here. That should cause it to start reading again. That's good. So we're going to turn the enable switch back off, and it's going to read in one more block of data. And it did that. So now it's paused and it's waiting for us to go again. So we want to do the compute switch to go. It's going to hit the typewriter and type some stuff out. Yeah, and then it's going to read one more block in. And then I hit the typewriter again. Okay. Okay, now it's paused and my notes are coming to a rapid end here, but we're gonna type some stuff in here. So we're gonna do a 00 tab slash and then a 2VZ tab S. It hits the typewriter, it does some stuff. Then we're gonna do a V2Z tab S, hits the typewriter again, does a carriage return, and now we're in an interesting position where I have no more notes, but I've been messing with this. If I can get the right incantation going on, we should see something on the scope here. So I think we'll try something here. All right, I think I figured it out. It's /L tab S, and that seems to make it do stuff. You saw that there was a square wave on there temporarily. Right now it's doing a whole lot of blinking lights up here. And if I'm not mistaken, we should get some more square waves showing up here shortly. Yeah, there we go, check that out. Oh, that is awesome. That is very, very, very cool. Okay. What is this? Well, we're doing something a little kind of crazy here, and hopefully the next step of this is going to make it all very, very, very clear exactly what's going on. So I'm going to take the steps towards getting that accomplished, and then I'll come back in and explain everything that's going on. All right, let's pull out a little proto board here and solder a few 1 megohm resistors and a header to it. Then I'll slot in a pair of 0.01 microfarad capacitors and tie those into the resistors. Finally, I'll solder in another header and our proto board is ready for installation. I want it permanently mounted to the chassis, but kind of out of the way, so I'll just slot it onto this long stud here and tighten it down. Then finally, I'll solder some wires going from 2 packs on the door to our little proto board. Yeah, that's right. The machine has been working for like a week and I'm already modifying it. All right, I've got the camera way, way back, and because I'm gonna have to be doing a bit of running around here, and I've been like soldering stuff up, I've soldered some stuff to the doors, I've been doing all sorts of stuff showing you scope traces, and I haven't really said what exactly it is that I'm doing, and that's because if it works, I think it's gonna be pretty awesome, or it'll be hilariously bad. I don't know, but you can see I've got an additional tape kind of set up here in a little bit of a janky way, and that's because I'm out of cartridges. I need more of those little cartridges that you put on the front here. Maybe we can make some of those up someday. But anyways, there should be something pretty special on this tape. I mean, we've already done a lot of really special stuff. We've ran the first real deal program that a Bendix G15 has run in probably 30 years. That's pretty exciting, but I hope this is gonna work. So I'm gonna walk over to the typewriter here and I'm gonna type /5 tab /S. So -5 tab /S. Now it's gonna start reading. I'm gonna have to kind of hold it here because again, I don't have a cartridge. Whoa! Did y'all hear that? It made a noise. Can you hear it? It's playing music. It's terrible music! And I don't think it's quite right. It's supposed to be Christmas music. Now that I've had like a day to catch my breath from the insanity that just went down, what exactly happened? Well, we tried to play music on a vacuum tube computer from 1956. Granted, it didn't sound very Christmassy and it didn't sound very music-y, but this machine was outputting square waves that the Marantz amplifier was picking up and playing as tones over the JBL speakers. The concept works, but how is that even possible? Well, at System Source Museum, they have a ton of paper tapes and magnetic tapes and documentation, and Lloyd and Rob, two absolute legends in the G15 community, have been making regular trips to System Source Museum to archive all of that. Well, not the magnetic tapes yet. We haven't figured out a good way to archive those yet, but the paper tapes in particular have been archived and backed up. And among those paper tapes that they've been archiving, they came across a tape labeled Music Program and a tape labeled Christmas Music. And that's what we just tried to run. We loaded up the music program and then we tried to load the Christmas music data and we got that hilarious concoction. Now, I will say that if you speed up the sound that's coming out of it to double speed, it sounds a little closer to music. But if you were to record it and play it back at double speed, it would change the pitch, which wouldn't sound right. So we're fairly certain that the data tape that we have that says Christmas music is not for this version of the music program that we have. But how is this music program taking this concoction of vacuum tubes and wires and turning it into sound that's being played on the Marantz? Well, they had me, we found some documentation. That's the only way we figured this out. We found the music program documentation and they outlined how to modify it. You solder a wire to the read amplifier of line 2 and the write amplifier of line 3. You run them through some 1 megohm resistors into some coupling capacitors and then run that into your amplifier. So the sound that you're hearing is coming straight from line 2 and line 3 on the drum. So how are they making those lines produce sound? Well, we could actually see a bit of that when we punched the paper tape for the music program. The music program itself is only like 1 or 2 blocks long. The rest of the blocks that got loaded in were collections of zeros and ones. And depending on how many zeros and how many ones you have, you can change the essentially waveform that's on that drum. If you have 100 zeros and then 100 ones and then 100 zeros and 100 ones around that drum, it's spinning at a known speed. And then you're reading that data back, it's gonna look like a square wave. And then you can change the number of zeros and numbers 1 to get different square waves that give different tones. So they loaded up a bunch of tracks on the drum with different square waves that are made up of data, zeros and ones. And then whenever they want to play a tone, they copy the correct note from one of those tracks over to line 2 or line 3. And then the amplifier sees that and plays it as audio. And we were only able to get this far to get that program to run because of Lloyd's unbelievable work. He has a gate accurate, cycle accurate emulator that he's been building, and using that, we were able to look at a ton of debug information from the G15 and kind of figure out what the program was expecting. And that's kind of how we came to the conclusion that the data on the Christmas tape is not for this version of the music program. But this music program is not just a playback program. When we first started this, I typed in a couple of letters on the typewriter here, and we saw a waveform on the scope. And what I was doing there was actually programming a new song. So you can use this software to write new music. And Lloyd was incredibly unhappy with the result of the gobbledygook that we were reading in before, and he sat down and figured out how to program a new piece of music, and all I have to do is type -5 tab /s. It's gonna start reading in this tape that he punched for me, and Silent Night! Real deal Christmas music! Oh, that's so cool. That's awesome. I want to thank you all so much for watching, and I want to wish you all the best Merry Christmas ever.